Hello, everyone. Today we are starting chapter 4. As you can see, I altered the packet so that it's 2 packets. This first packet is what will be on your first quiz. So let's begin. So this lesson's actually pretty much review. So I want you to actually pause the video right now and see if you can label these triangles by sides and then by angles. And then we'll come back and you can check your answers. Okay, so welcome back. Our first triangle here is equilateral. That means all sides are the same. Isosceles is at least 2 sides are congruent. Scalene, no sides are congruent. By angles, our first triangle here is equiangular. All angles are congruent. Obtuse, 1 obtuse angle. Right has 1 right angle. And acute, all angles are acute. So every triangle has actually 2 names. It can be named by the sides and angles. So let's take a look. Example 1. If point M is the midpoint of JL, classify triangle JKM. So JKM is this triangle right here as isosceles, equilateral, or scalene. Explain your reasoning. So when I look at this, I know that M is the midpoint of JL. So that means JM is congruent to JL, and it was labeled that LM is congruent to KM. So if that's the midpoint, that means this is 0.75 because it's half of 1.5. This is 0.75, which means this is 0.75. So now if I look at JMK, all 3 sides are 0.75. Therefore, this is equilateral. All sides are equal. So now if we look at number 2, it says find the measure of the sides of the isosceles triangle. So again, it's telling us in the drawing that AC is equal to BC, which means that 4x plus 1 is equal to 5x minus 0.5. So I do that algebra, and I get x equals 1.5. So I need to find the measure of all the sides. So I use my calculator. And up here I do 9 times 1.5 minus 1, which equals 12.5. And then 5 times 1.5 minus 0.5 is 7, which means this is also 7. Example 3, find the measure of the sides of triangle DEF and classify it. So I can plot that. So D is negative 5, 9. E is 2, 1. And F is negative 8, 3. So none of those lines are horizontal or vertical. So the only way I can find all 3 sides is to use the distance formula. Distance formula is something we learned in chapter 1, which is D equals, that's a horrible D. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I need to do that for all 3 sides. So I want you to pause and do that and come back. Okay, so you can see I left all my answers in radical form. I didn't even simplify them because I really just need to know if they're the same. So I found D equals the square root of 113. FE is the square root of 104. FG is the square root of 45. Since those are all different, it is a scalene triangle. Now, triangle angle sum theorem. You've learned this before. So what it is the sum of the interior angles of a triangle is 180 degrees. Always. We're going to prove that right now. So one method of proving that is to start with a triangle where I know that this exterior line AB is parallel to CD. So knowing that that's parallel, I can conclude that angle C and angle BEC are supplementary. So I'm saying, and the reason for that is, so one is given. The reason for that is same side, interior angles are supplementary. Actually, I don't want to do this proof that way. Rewind. Sorry about that, folks. What I actually want to say is that angle C is congruent to angle AEC. And that is if parallel lines, alternate interior angles are congruent. And then I can say that angle D is congruent to angle BED. And that's for the same reason. Parallel implies alternate interior angles congruent. So I know C is congruent to AEC because those are alternate interior angles if C is the transversal. And then angle D is congruent to angle BED because DE would be the transversal, and those are alternate interior angles. So now I can do angle addition, and I can say angle AEC plus angle CED plus angle BED is equal to angle AEB, and that's angle addition. I know that angle AEB equals 180 because it's a straight angle. And then substitution says angle AEC plus angle CED plus angle BED equals 180. And then I'm going to do one more substitution because I know that AEC is equal to angle C. So that's angle C plus, and then CED is part of my triangle, so I'm going to leave that one, plus angle D equals 180. And that proves that the sum of the angles will always add to be 180 degrees. You will not be asked to duplicate this proof. So let's try this example. If the degree measures of the angles of a triangle are represented by that, find x. Well, we know that the angles always add to be 180. So therefore, 2x plus x plus 10 plus 3x minus 10 equals 180. So I want you to pause and finish the rest of this example and example 2 and 3 and come back and check.